In this video we're going to discuss the power rule, and we're going to define that as y is going to be equal to x to the n, and y prime, which is going to be the derivative of y, the rate of change of y, will be then equal to n times x to the n minus 1. So in solving these problems, it's really important to be able to figure out what your n is and be able to pull it out front and multiply it by the original function lowered 1 degree in the exponent. So let's get started. So okay, let's see. The first example could be if we had y is equal to 3x squared. So if we look at this, these look a lot alike. The 3 here is going to be just pulled out front. That's going to be a constant, and that's going to multiply the derivative by a constant value. So that shouldn't be too much of a problem there. If we look at this, we have it where n, for this portion of it, if we just concentrate here, it's going to be looking a lot like, our n will be 2, because it's going to be x raised to the second power. So we can write over here n is equal to 2, and then if we had y prime, it's going to be equal to our 3, which we said can just say out front as a constant multiplier. 3 times our 2 here times x raised to the n being 2 minus 1. So that's x to the first power, which is just going to be x. That's going to be equal to, if we multiply this out, 6x, and that's our answer for y prime for that first example. Okay, let's move forward. So let's see. What if we had something like y was equal to 1 over x to the 4th power? This is not in a form that we can do very easily. As you do a lot of these problems, you could probably just kind of shortcut your way through it, but it's probably best with the rules of exponents to express this. And for those of you who don't remember the rules of exponents, they state that if we had 1 over x, that's going to be equal to x to the negative 1, and if we had 1 over x squared, that's going to be equal to x to the negative 2, and so on and so forth. So this is 1 over x to the 4th power, so that's going to be equivalent to x to the negative 4. So now we've got this x to the negative 4. That's in a form that we can use. In this case, we're going to have it where n is equal to negative 4, and then our y prime can be equal to negative 4 times our x to the n minus 1, so x to the negative 5, and that's going to be our answer. Okay, example number 3. So let's do something that has some fractions in it. So let's say we had y is equal to, let's see, 1/2 times x to the negative 7/2. So this is going to be a little bit harder to solve. Shouldn't be too bad. So in this case, we're going to have it where that 1/2 can kind of just hang out front as a constant multiplier, and then we can take the rest of it and plug in our power formula and see what we get. So it looks like n is going to be equal to negative 7/2, and if we take that, where we have y prime is equal to our 1/2 times our n, which is going to be negative 7/2, x to the n minus 1. So in this case, n minus 1 is going to be negative 9/2. We'll get, multiply this on through, y prime is equal to negative 7 over 4, x to the negative 9/2, and that's going to be our answer for that problem. Well, that's all the space we have on this page. Feel free to make any comments on the section below, and hope this has been helpful. Thank you.